Hello everybody. I hope everyone is having a great day so far. Today we're going to talk about determining if a relation is a function. We've heard the word function used in this class at times to explain linear functions, but without actually understanding the full definition of a function. And please also keep in mind that determining if a relation is a function is also a bit different than function notation, which is the f of x. The first definition we're going to talk about is a relation. A relation is quite simply a set of ordered pairs. So any set of ordered pairs is a relation. So for example, I could write down 3 or 4 or even 5 ordered pairs. Right now I'm going to write down 3. So here's 3 ordered pairs. And that would be a relation. Okay, the brackets signify the grouping of the 3 ordered pairs, but those 3 ordered pairs would be a relation. We could also make a graph of ordered pairs, or a graph of any type of inputs and outputs. We could have a graph of something. That would also be a relation. Domain. You've probably heard that word before. A domain is the set of all x values. And remember, our x values are inputs. So if we take the 3 ordered pairs we wrote above, the domain would be 3, 1, and -2 because those are our x values. Sometimes you might see the domain values written in ascending order from smallest to largest, but that's not really that important. The most important thing for you to understand is that the domain are your x values or your inputs. The range is therefore the set of all y values or outputs. So if we take, again, the above relation, write down what you think the range would be. Okay, now I gave you a chance to think about that. The range is simply the y values. Now we actually have -4 that repeats itself twice. So because that's actually the same -4, I won't write it twice. I'll just write it once, even though there's 2 -4s as the y values in the ordered pairs up here. So I'll write down -4, 3, and that will be my range. So if a value repeats itself, when you're writing the domain and range, you do not write the value again because that value is one value. Okay, even though it appears twice. Okay. Now, the key definition for today is a function. And again, please don't confuse this with function notation. A function is a relation in which every x value, remember x value could also be called an input, has exactly one y value or output. So again, a function is a relation, and remember a relation is a set of ordered pairs in which every x value has exactly one y value. So we're going to determine if relations are functions 3 different ways, or actually 4 different ways. We're going to look at the ordered pairs, simply. We're going to look at graphs. And we're going to use what's called the vertical line test. And we're also going to look at a mapping diagram. So I think I said 4, but actually 3 ways we're going to look at. So those are the 3 ways we're going to look at in determining if a relation is a function. So let's start with simply ordered pairs. So for example 1, and the question is going to be for all these problems, is this relation a function? So for the first example, I'm going to have negative 3, 7, 2, 4, 2, negative 1, and 4, 0. So here we have a relation. It's actually 4 ordered pairs. Really quick, I want you to take a second to write the domain and range. So before we talk about is this relation a function, can you please write down the domain and range? Okay, so hopefully you got a chance to work on that on your own. The domain for this relation would be negative 3, comma 2, comma 4. Remember, 2 repeats itself twice, so I actually don't write it twice when I'm writing it in my domain. For my range is the y values. So for our y values, we have negative 1, 0, 4, and 7. I'm actually doing my best there to write them in ascending order, going from smallest to largest. But you don't necessarily have to. I'm not too picky on that. Most important thing, domain is your x, range is your y. You could also get domain and range by looking at a graph, which we'll talk about tomorrow. Now, is this relation a function? The answer is going to be no, and here's why. Because for one x value of 2, basically when you have ordered pairs, it's saying I'm putting in 2 into a function, 2 is my input, and I'm getting out 4. But I also again have the input of 2, and I'm getting out negative 1. So for one input of 2, I get 2 different y values or outputs of 4 and negative 1. So therefore, this is not a function because each input can only have one output. It cannot have 2. Okay? So that's how you look at ordered pairs to determine if a relation is a function. Usually in most cases, if your x value repeats itself, and in this case 2 repeats itself twice, it's not going to be a function. So if you have an x value that repeats itself, it's most likely not going to be a function. Okay, so now we're going to look at graphs to determine if a relation is a function. So let me make 2 graphs up here. So I have 2 coordinate planes. The first one I'm just going to make a line. And the second one I'm going to make a curved shape. It's actually called a parabola. That's not important for this lesson right now. So we'll call these A and B. So what we use for graphs is called the vertical line test. Okay. And if I could draw a vertical line that hits my graph in more than one place, it's not going to be a function. Okay. So if I could draw a vertical line that hits it in more than one place, it's not going to be a function. So for A, this is going to be a function because no matter where I draw my vertical line, it only hits the graph in one spot, so therefore it is a function. For B, as you can see, it's not going to be a function because if I draw my vertical line here, I'm okay. If I draw it on the end, it only hits it in one spot. But if I draw it right here, it hits it in 2 places. Therefore, it's not a function. And this actually works because along this line is actually one x value, but each of these points would be 2 different y values. So for example, just by gauging my graph, if that's 10, this might be 10, negative 5, let's say. And this point up here might be, 10, 6. So for one x value, you actually get two different y values. So that's why the vertical line test works. But again, that is not a function. And the last way is called a mapping diagram. So for a mapping diagram, what you're going to have is you're going to have two shapes. They're usually either two rectangles or perhaps two circles. The first shape will be your domain or your x values. The second shape to the right will be your y values. And what you'll see is you'll see lines going from the x values to the y values. So here, let me make the problem. So here would be the problem. Let's say you're given. This is the mapping diagram. So is this a function? And you might know the answer just by looking at it, but the answer for this problem is going to be no, it's not a function. And here's why. For one x value of -1, we actually have two different y values of 0 and 1. So for one x value, this particular x value of -1, we get two y values, making it not a function. When you have a mapping diagram, there could only be one line, or needs to be one line emulating or coming from each x value. So if there's more than one line coming from an x value, or if it doesn't have a line coming from it, it's not going to be a function. So again, each x value could only have one y value for a relation to be a function. So there are the three ways in determining if a relation is a function. Hopefully you found this video helpful. Make sure to answer the questions throughout the video and have a great day.